This third and last video on for this section, we have a couple other functions, common functions that we need to know that are used in the text and used in the homework and on tests. The first is an absolute value function, y equals absolute value of x. It can also be written as the square root of x squared. As long as x is real, that's absolute value. And it looks like this V shape. The right-hand side looks like y equals x, and the left-hand side looks like y equals negative x. Right? And the vertex here is at the origin. Now, this point here, you'd go over 1 and up 1, over 1 and up 1, just like with everything else we've done, or like the parabolas. If this had a coefficient, that is a number in front of the absolute values, like 2, you'd go over 1 and up 2, and put a dot, and that's you draw a line through the origin and that point to get the correct line. So it makes it skinnier. And then you go left 1 and up 2, and that would be a point on your graph, so you get something more like that. Right, so these all act kind of the same way. All functions do actually act this way. You just have to know the initial shape. Now this one is one you may or may not have seen before. This is called the greatest integer function. And it's got this kind of y equals, it's got a bracket with an extra vertical line, x, and then the closing bracket with the extra vertical line. It's called the greatest integer function. There's other ways of writing it as well, but this is the way we're writing it. So the definition is that it is the largest integer less than or equal to x. So say I had x is 5. Well, here, I did some examples for you. So say x is negative 1. The largest integer, so the furthest to the right on the number line, that is less than or equal to negative 1 is negative 1. And in fact, that works for any integer. This just spits out the same integer. You put in an integer for x, and you get the same integer out. Right? So the greatest integer of 1 is 1, etc. Now, the interesting thing is when they're not integers. So suppose I had negative 0.1. I want the largest, picture it on a number line. Draw it if you need to. Negative 0.1, you want the largest integer less than or equal to that. That would be negative 1. Even though it's closer to 0, but it would be, so you're not rounding it off, it would be negative 1. With negative, the greatest integer of negative 0.9, we're looking for the largest integer less than or equal to, well, it couldn't be equal because that's not an integer. So the largest integer less than negative 0.9, which is negative 1 again. Okay. The greatest integer of 0.1, the largest integer smaller than or equal to 0.1, largest integer is 0, so that would be 0. See how it goes? And with 0.9, it would still be 0. Right? What if it's 1.1? What would that be? Largest integer less than or equal to 1.1. That would be 1, yeah? 1.9 would also be 1, etc. Okay? So you have to understand that. The graph of this function, I graph the integers first, so 0, 0, 1, 1, 2, 2, right? And then I use the negative 0.1 the greatest integer, negative 0.1 from here, is negative 1. So at negative 0.1, I have to be negative 1. And all these on this interval are down here at negative 1. Right? And there's an open dot there at that end. So otherwise it wouldn't be a function, right? And you just fill the rest of that in. If you forget which side of the line is open, just think it through. Well, just draw the integers first, and then the other one has to be, draw the 1, 1, 2, 2, 2, 3, 3, 4, 4. The solid dots here, draw those first, make them solid, then the other one has to be open, right? And try a point like this one and see where it is. Because people will sometimes put this one here and this one here, so they'll put these one too high and mess it up. But so you just try a few, and they'll give you a feel for how it goes. So this is sometimes called a step function, or sometimes it's called a step function.